All right, ladies and gentlemen, we're going to talk quickly about power, okay? So we've talked about current, we've talked about resistance, we've talked about potential difference. So we've talked about a lot of these different things that we deal with. Now the last thing we're going to talk about this unit is power. And power is essentially a measurement of how much electrical energy gets turned into some other form of energy, okay? So if you think about it, when we put a light bulb there, what happens? The electrons go through, and what happens when they go through the light bulb? It lights up the light bulb, sure. But what's happening within the light bulb? It's a resistor that's converting the energy from electrical energy to light. Well, if it does a lot of that, it's using a lot of power. You with me? So how much we measure, we're really measuring how much this thing is able to convert electrical energy into some other form. And ironically enough, we all know, and you guys have probably dealt with a light bulb before, there's different types of light bulbs, right? There's a 60-watt bulb, and an 80-watt bulb, and a 100-watt bulb. What does that really mean? A 100-watt bulb, is it brighter or dimmer than the 60-watt bulb? Brighter. It's brighter. Well, why is it brighter?
It's got more electrical power.
It's converting more energy from electrical energy to light energy, okay? So the measurement really, remember before we had a power formula, it was work divided by time. It's the same thing, but it's an electrical version of that, essentially. And remember, what the old school work was transferring energy to another object. Well, it's the same concept, basically. And remember, our units were what? Watts. Well, they still are, okay? So in the electrical form of power is P equals IV, okay? Now, P equals IV says the power is equal to the current times the voltage, okay? Or the potential difference, okay? I didn't put on here, we know the power is in watts. What is I equal to? What is I measured in? Amps. And what's V measured in? Volts, okay? Now, I do want you to see that there are two other potential power equations. And what I'm essentially doing is I'm combining V equals IR and P equals IV. If you look here, guys, up here, okay? So if I plug in IR where V is, I end up with one of the formulas for power, which is I squared R. You with me? I'm just taking that, plugging in that V, and it's I times I, which is I squared, times my R. That's another potential formula if they gave us current and resistance. It's not going to be on your formula sheet, but you could easily derive it by just combining these two, right? Now, if we solve for current, we would get current equals voltage divided by resistance. And then we go and we plug in voltage over resistance for current, and we end up with P equals V squared over R, another potential formula for power. If they were to give us voltage and resistance, we can use that one, okay? So, that said, there's three different real formulas. And when we're converting energy, electrical energy, it's not always into light. It could also be into heat, like the stovetop on an electrical stove, right? It could be mechanical work. It could be lots of different things. But essentially, it can be converted, it's energy being converted from electrical energy to some other form, okay? Now, I want to show you a couple different types of problems that you might run into so that you can handle these types of problems. And then I'll turn you loose on the we do. You guys can finish up the we do, and we'll call it a day. So you might see a formula that says 110-volt toaster oven draws a current of 6 amps on its highest setting as it converts electrical energy into thermal energy. What is the toaster oven's maximum rating? In that case, we just plug in I and plug in V, and we chug it out. Nice and easy, right, guys? You guys can handle that, okay? What about, it says an electrical iron operating at 120 volts draws 10 amps of current. How much heat energy is diverted by the iron in 30 seconds? In that situation, you see I'm going to use P equals IV to get my power, but then what you might run into is really they want to know power. We know power is also equal to work divided by time, right? So they want to know really what they're asking for is this work. So if they gave you a question like that, then what you would do is you would just use this formula to get your power and then plug in the time that they give you and solve for the work, okay? Last one, a potential drop of 50 volts is measured across a 250 ohm resistor. What is the power dissipated in the resistor? And you'll notice that if we use P equals IV, here we're given voltage and resistance, but we don't have current, so we can't use that form of the formula. That's where these other formulas come in. You combine Ohm's law, V equals IR, and power formula, P equals IV, to get your formula, which or you can solve for the current in V equals IR, and then plug it in, okay? So that's one option. The other option in this situation would be to just use the P equals V squared R formula that you can derive from combining these two equations, okay? So that said, those are the types of problems that you're going to see in this we do. So go ahead, and with the last 11 minutes, I want you guys to do the power we do, please.